We will now look at another example of proving trig identities. On this example, you want to prove that this big, ugly left-hand side equals 2 tangent of theta. So I'm obviously choosing the left-hand side to start with, and I want to eventually show that it equals 2 tangent of theta. One thing to notice is that within the left-hand side, you see that you have a unit that is being squared. First, realize that the unit being squared does not mean that you need to square each term on the inside. Rather, it means that you need to take secant of theta minus tangent of theta and write that factor multiplied twice. In other words, secant of theta minus tangent of theta squared means secant of theta minus tangent of theta times secant of theta minus tangent of theta. We still have the plus 1 on the end. The denominator I'm going to leave alone for the moment. I have secant of theta, cosecant of theta, and then minus tangent of theta, cosecant of theta. In the numerator, I need to FOIL the two binomials. Doing that, I'll have secant of theta times secant of theta, which is secant squared of theta. I have secant times negative tangent, which is negative secant theta tangent of theta. I have negative tangent times secant of theta, which is negative tangent of theta secant of theta. I have negative tangent of theta times negative tangent of theta, which is positive tangent squared of theta. And then I still have the plus 1. The denominator, once again, I'm going to leave that alone for the moment. One of the things that you need to do is when you're proving a trig identity, make sure that you are including the argument for that trig function. In other words, the argument here in this case is theta. I don't want to just say secant squared. I need to say secant squared of theta, and be sure to write all my arguments in my expression. Now, from this point, there's a couple of things I can combine. There's something I can rewrite. First of all, these two terms are actually the same term. In other words, negative secant theta times tangent theta is the same thing as negative tangent theta times secant of theta. They're just multiplied in a different order. Since they are actually the same term, then I can add them together and say that they are equal to negative 2 secant of theta tangent of theta. I'll leave the secant squared as it is, and then this is negative 2 secant of theta times tangent of theta. Now, at the end here, notice I have a tangent squared plus 1. I have a Pythagorean identity for that. Tangent squared plus 1 is equal to secant squared. The denominator, once again, I'll leave that alone. Okay, in the numerator, there are two terms I can combine. I have a secant squared theta at the front and a secant squared theta at the back. There's two of those, so that would become 2 secant squared of theta, and then minus 2 secant of theta tangent of theta. Okay, I'll copy down the denominator. Okay, from this point, I'm done combining like terms. There's nothing I can collect. However, the numerator and the denominator both share factors. In the numerator, I see that both terms share a secant factor. They actually also share a 2, so I'm going to factor out 2 secant of theta. Okay, doing that, I'm going to be left with 1 secant of theta in the first term, and then minus a tangent of theta on the second term. Okay, in the denominator, I notice that both terms have a cosecant in common. So I can factor out that cosecant of theta, and then I'm left with secant of theta minus tangent of theta. Now, what's happened is I've ended up with two factors in the top and the bottom that are equal. I have a secant minus tangent of theta, and a secant minus tangent of theta that can cancel out in the numerator and denominator. That leaves me with 2 secant of theta over cosecant of theta. Now, from this point, I'm going to rewrite my secant and my cosecant functions in terms of sine and cosine. Secant is 1 over cosine of theta. Cosecant is 1 over sine of theta. Okay, from what I've learned prior, I know that to divide fractions, I keep the first fraction as it is, I change division to multiplication, and then I flip the second fraction. Okay, doing this, I get 2, and then I can multiply those two fractions together. 1 times sine of theta is just sine of theta. Cosine of theta times 1 is just cosine of theta. And then I recognize this as an identity. 2 times tangent of theta. And I have achieved what it was that I wanted to prove. Going back up to the top, I'd wanted to show that the left-hand side was equal to 2 tangent of theta, and that is what I've done. This concludes this lesson on proving trig identity.